Oh, we're going to talk about fuel control. Loop status. Now, what's loop status? Loop status tells us if the fuel system is compensating for the exhaust O2 content. Basic meaning, in closed loop, it responds to the O2 sensor. In open loop, it ignores the O2 sensor. So loop status would tell us if that fuel system is actually compensating for that O2 content in the exhaust system after combustion. That's your loop status. That basically means closed loop responds to the O2 sensor, O2 ignores the O2 sensor. And basically, if I'm ignoring the O2 sensor, I'm open loop and not responding to the O2 content. If it's in closed loop, it's responding to the O2 content. Now when I say O2 content, O2 sensor, oxygen sensor generates the voltage based off the O2 sensor content, O2 content. Then you got airfield ratio sensor, same concept, and the fuel trim also helps us indicate what's going on with the fuel status or the fuel trim in the system. Open loop. No control response to the O2 sensor. Input is used during cold start and while open throttle. So at while open throttle, deceleration, and cold start, the fuel goes in open loop. Closed loop, computer directly responds to O2 sensor input. Maintains stoichiometric mixture, creates a binge and purge of the catalytic converter. Basically what that means is, an open loop again, I'm ignoring the O2 sensor and not paying attention to the content exhaust system, O2 content exhaust system. Closed loop, I'm using the O2 sensor. I'm looking at this loop status to tell us if the fuel system is in control about watching the O2 content. Let me say that differently. Closed loop meaning I'm using the O2 sensor to respond back and forth to talk to the computer, and that helps control the air fuel mixture to try to keep the fuel trim within range. So this means that it's listening to the O2 content in the exhaust system by using the O2 sensor. Hope that makes sense. Here's the O2 sensor, the three types: zirconium, titanium, and airfield ratio. The most common one is zirconium. It generates its own voltage. There are some titanium and airfield sensors, but we're just going to talk about the zirconium right now. The oxygen sensor signal is used to help the PCM maintain a proper fuel control. That's what I was trying to say earlier. And is secondary used for the following: open loop, closed loop. The O2 sensor is the heart of the fuel control system. If that's been ignored, the fuel control system is out of control. It's in a default value. When the computer listens to the O2 sensor, it's in fuel control. So anytime the PCM ignores the O2 sensor, it's not in fuel control. When the PCM listens to the O2 sensor, it's in fuel control, or at least trying to maintain a good fuel control. So this is basically our loop status. Open and closed loop is our loop status. Again, it tells us if the fuel system is compensating for the O2 in the exhaust system, O2 content in the exhaust system. But we also use the O2 sensor for EGR diagnostics on some applications, monitoring catalytic converter, almost every car after 96, and secondary air and EVAC system diagnostics. And this was made up of, and don't worry about it, you don't have to remember how the O2 sensor, zirconium plates, platinum plates. It's just telling you what it's made up of. The construction of it here. As a center element made of ceramic material called zirconium. 2 platinum electrodes make up the inner and outer surfaces of the center element. And internal temperature must be kept above 600 degrees Fahrenheit. So basically, this sensor, before it starts working, has to heat up to 600 degrees Fahrenheit before it starts to operate. And you can see on this one, it is telling you the O2 sensor generates its own voltage. The O2 sensor is like a little battery. Once they heat up to about minimum 600 degrees Fahrenheit, it starts to generate a voltage between 100 and 900. It's going to go from 0 to 1,000 millivolts. The range is usually somewhere between 100 to 900 millivolts, switching back and forth, up and down. Lean, rich, right? Low voltage, high voltage, low voltage, high voltage. Okay? But it generates its own voltage, right? On the zirconium type. Some computerized control systems have a heater circuit inside of it, so it can start going in closed loop faster. That one receives voltage and the ground. But the actual O2 sensor generates a voltage on a zirconium O2 sensor. Okay, that was a basic overview. Any questions, hit me up in class. Email or social media, wherever you're at. Thanks.